Okay.
All right. Thank you. Thanks, everyone. I'm Adam Leventhal. I work at Delphix as a software engineer. As Brendan helpfully pointed out with the picture of Brian sitting on my knee, I was also one of the inventors of Dtrace. This is one of the stranger talks I've been asked to give. It came about in a kind of funny way, where my former colleagues, Keith and Robert, who are now at Joyent, they said, give this talk, this is the title. And as I was thinking about what this talk was about, it's kind of interesting, right? There's a lot baked into this. Illumos innovations that will never be in Oracle Solaris. So first of all, there's the Illumos innovations, very nice thing to talk about. I'm looking forward to getting to that part. And then the will never be in Oracle Solaris. And there's a lot of complicated feelings, I think, associated with that. And so I started looking for rhetorical inspiration. And I thought, of course, of Brian Cantrell, who's given a lot of talks, commentary about Oracle and Solaris and so forth. And I think when Robert and Keith asked me to give this talk, I think they had something like this in mind. And I think they really wanted the kind of Brian, somehow, even when Brian gives these talks, he'd get beat up by Larry, even when he's giving the talk. So I thought of that as kind of rhetorical inspiration, but I wanted to look, then I thought of kind of another hero of mine, and thought more of this kind of, no, Brian, I won't tell Larry to do that to himself. I'm glad everyone watches TV. And of course, it reminds me indelibly of this. Everyone saw this coming around. Does everyone know the genesis of this particular meme, like where the actual picture came from? I know if Dave Pacheco were here, he'd be shouting it out.
It's from the Simpsons, actually.
That's right. It's Abe Simpson. Old man yells at cloud. And of course, as I was thinking about this presentation and thinking about Brian versus Larry and Abe Simpson yelling at the cloud, I couldn't help but come up with this picture that other people have talked about today. Old man yells at cloud computing. So with that as kind of a backdrop, I want to talk about Oracle Solaris very briefly. And I realized as I tried to fill up this slide with content that it was very difficult to do. So what's new in Solaris 11? I went through the document. Has anyone looked through the what's new in Solaris 11 document that everyone's had on their pages? It's amazing how much someone could write about so little. And you really realize that there's no unifying theme. There's like a bunch of stuff in IPS. There's a bunch of stuff that had already been done in OpenSolaris and Fishworks and kind of was pushed off to the sides. And then there's a bunch of stuff around like networking and sort of network virtualization and that kind of thing. So I guess it's like networking plus IPS equals cloud. Good enough, right? Let's go with that and put it on a box, and as Brendan showed us, on a bus as well. Obviously, Oracle Solaris cares tremendously about the Spark platforms, something I think that we're a little conflicted about how much we care about it, but so it goes. But their audience, if you look through the list of features, does anyone, there's a new command line option in ZFS. Does anyone know what it is in Oracle Solaris 11? Matt?
I saw the Zfs snap.
Correct.
There's a shortcut for Zfs snap.
Correct. I'm really impressed that you saw that. Yes, you don't have to type all the way snapshot. Man, saved like 50% of my time right there. So Oracle Snap is now an alias for, ZFS Snap is now a ZFS snapshot. But that was like right there in the what's new. That's like front and center. And it makes you realize what their audience is for Oracle Solaris. And their audience is existing customers, is Spark users, is system administrators. I think it's very narrow in focus. Let's see where I'm going from here. So, Illumos, we have a very different audience, and we have a very different focus. We are building companies, and we saw this in the first panel that Deidre hosted. We're building our companies on the technologies that are baked into Illumos and came from Solaris and OpenSolaris and so forth. So, in terms of who Illumos is for, it's really for these companies, for people building on top of ZFS for these different types of situations. For Dtrace, as Brendan kind of walked us through in extraordinary detail, for virtualization, as Jerry just walked us through. So that is one core body, and all of those developments, all of those innovations have been the fruits of actual problems that we've encountered in our businesses as we've addressed customer problems or wanted to take our businesses into new and differentiated territory. The other part, and I think this definitely appeals to this group of people, is for developers. So there's obviously a great development community working on top of Illumos today. People at these companies and people, kind of working elsewhere. People whose business is not bet on top of Illumos. But we're seeing innovations in Dtrace and MDB and other kinds of developer tools. So, getting back to the title I was asked to speak on, there's the innovations that are in Illumos, but recall that these are two very different products, two very different end users. There's the kind of narrow niche, Spark, sysadmins, people who are trying to, for whom new packaging systems are a boon because I was just by the Oracle Solaris booth, and someone's proudly showing me an email where a customer's saying, with Jumpstart it used to take 5 hours, and now with IPS it takes like 20 minutes or something like that. Which is not really a problem we care about too much, but it's a problem that Oracle Solaris is addressing, and I think we're moving on to other kinds of differentiated problems. So, again, I was asked to speak about unique technologies in Illumos, and I know that Brendan was going before me, and Jerry was going before me, and going to steal a bunch of my thunder there. And I wasn't going to go down how could I summarize all of the things that have happened. So instead, I just decided I'm going to pick some things that I really like and that you might not know about, and talk about them. And if there's time, I'd like to hear things that are that you think are particularly innovative in Illumos, and let's talk about those as well. So the first feature that I think of, the first innovation in Illumos that I think of, is Zfs Feature Flags. And I think this was a really important innovation and kind of one that helped define who we are as a community. So this is, the problem was this: in the days of Oracle and the days of Sun, when we were working on kind of a single continuum, we organized our ZFS features just along a straight line. And, version 13 had this, version 14 had that, and so forth. Now, as we were becoming a distributed community where people at Nixenta and Delphix and Joyent might be working on different technologies which would change the on-disk format, we didn't want to conflict on what version 35 meant or 36 meant. So Matt Ahrens, who was one of the original authors of ZFS along with Jeff Bonwick, and some others, came up with an idea for ZFS Feature Flags. This was, rather than having that single continuum, have each feature be its own discrete enableable entity. Basil Crow, who's my colleague at Delphix, worked on that during his internship, and Chris Seiden finished that off and got that integrated into Illumos. And in fact, his blog is where I cribbed this information from. But feature flags, again, we can look through the, I wanted something on this slide to kind of ground us in what it actually means. But the significance of feature flags is that, again, it enables the development that we, that we want to do in Illumos, and enables the, us all to kind of work together productively. Chris did also one of the early features, async destroy. Chris, that was mostly you, right? Or maybe exclusively you. So one of the problems in ZFS is you type ZFS destroy, and if there wasn't much data to destroy, it would return immediately. And if there was tons of data to destroy, it would take a really long time, like a really, really long time. And so Chris made it so that it returned instantly and would go off behind the scenes and delete the data. This is a problem that came about not because of some system administrator, although we certainly saw that problem as system administrators ourselves, but it came about as a problem that we saw at Delphix that we had previously worked around in really goofy ways, but were able to solve more elegantly. I assume that was some chuckle from someone at Delphix who saw what we had done. But it was pretty hard. Yeah, okay. Yeah, we've all had this problem, and it's pretty horrible. So again, Zfs Feature Flags, one of my favorites. This is a great one. This is this integrated yet, Chris? Yeah, it's up for review, right? So I'm counting this chicken before it's hatched, but it's really neat. So you'll have to let it slide. So we call this feature Zfs Not Rights, and this is something that George Wilson, who's sitting in the back of the room, also a colleague of mine at Delphix, has worked on. So let me set up the problem a little bit. Delphix, we're a database virtualization company. This is what we tell CIOs. What I'll tell you is that we're an intelligent storage proxy. So we sit there between their SAN and between their database, and we are just an NFS server that effectively reduces the duplicated data down to a single copy. We do that by ingesting all of the data onto a ZFS dataset, and then taking a ZFS snapshot and a clone to instantaneously provision out new copies of the data. So this is relevant in the context of our SQL Server product. SQL Server is interestingly broken in that you can't take incremental snapshots. So, or incremental, incremental snapshots. So you have to just recover, you have to take a copy from the beginning of time. So we don't do that. You know, in Oracle, we'll take the incremental snapshots and build them up over time. But we can't do that with SQL Server. Instead, what we have to do is take these log records, and we can replay the log records to construct the state of the Microsoft SQL Server database at any arbitrary point in time. But there are some operations that don't appear in the log. So in those situations, we actually do have to go and get a full backup. And so we were talking about this and quickly realized that one of the benefits of Delphix is we take your many copies of your database and shrink it down to a single copy. As the ZFS is today and won't be tomorrow or Thursday or something, if we take that full copy and dump it onto ZFS again, it would take up just as much space. So if we've got a 1 terabyte database sitting there and we take a full backup of that 1 terabyte database again on ZFS, it would take up an additional terabyte, even though most of that data hadn't changed, even though that non-logged operation didn't incur too much data change. So what George came up with is something pretty...
Why don't you just use dedupe?
Great question, Matt. Why don't we just use dedupe? Yeah, so dedupe. I'll go on that. I'll take that bait. Dedupe. So in the heavy Sun days and then less heavy Oracle days, we worked on dedupe, and everyone knows that dedupe is in ZFS, and I think everyone also knows that dedupe don't work so good. Yeah. Actually, it's very demoable. You can, if you make a file, you make another file, like it has the same content and copy it over. Look, it didn't take any more space. And then you get like 15 files, and all of a sudden, like performance falls on the floor. Maybe it's not 15, maybe it's like 150, maybe it's 1,500, but it's a relatively small amount of data before things really fall over. So dedupe would have solved this problem. We are writing the same data over and over again. But we actually can be more narrow than that. So while it might be that we're writing the same data to a different location, it turns out we're writing the same data to the same location. We're overwriting that file effectively, right on top of itself. So we chose a different approach, one that was fairly feasible. In fact, we used to call this feature nano dedupe. So it was like dedupe, but instead of having your DDT be your whole pool, your dedupe table was the single block that you were writing to. And it just said, does it match the same block that I already have? Yes, then good enough. We don't do that by, if we have a cryptographically secure checksum, we don't bother checking the content of the data. We just say, great, your SHA-256 hash matches, on disk matches what I was about to write. I'm just gonna skip that write. So again, neat innovation. in Illumos generated from one of the use cases, in this case, something that came out of Delphix, but I think we've seen these other instances of this. If there are questions, feel free to holler out, or if people want to hack it. Yeah,
that last one's up for review right now?
Yeah, that's up for review now.
Okay, must spend cycles, thank you.
Yeah, there you go. Yeah, it's a pretty neat feature. I think that like the kind of obvious question is, well, what if I'm writing some other block that happens to have a SHA-256 hatch which matches exactly? It's like, well, it's your unlucky day.
It's a 1/128 chance with birthday effects taken into account, and if you find such a block, you want to panic and know the contents
Right.
of
So it's very unlikely to happen, and you know what? If it doesn't work for for your use case, then turn it off. And for the Delphix use case, it turns out it works out great because Microsoft SQL Server is not going to write a block because it's very structured. It's not going to write a block that has the same SHA-256 checksum, and I bet it'd get into other kinds of trouble if it tried to do that. All right. Ooh, Dtrace usability. So this is obviously a favorite one of mine. So I'm going to stop with the slides, and I'm going to go to my terminal. You're still here? Terrific. All right. So at the last hackathon, we have another hackathon coming up on Wednesday. People came up with a bunch of neat Dtrace usability features. I hold these out because I think they're kind of fun. They impact my everyday life. Like literally, I use these things every day. So I'm going to show the first one, and this is a little bit of a teaser, but it came up earlier. I was just at the Dtrace for Linux talk down the street, and this almost exact example came up. So I think I have this in my buffer. So in the world of old Dtrace, if I run the script and I say profile twice a second, and then trace out the timestamp. I'm going to run it for a second, and then ask someone who did not work on the feature or code review it what is going on here. So notice I've got 2 from CPU 1, and then from CPU 0, then 2 from CPU 1. And if you look carefully, these are out of order. I can see I've got 35 down here, and 34 down here, and 40. So what are we seeing with Dtrace here? I'll take that, yeah.
It's hard to know what time it is.
So it's hard to know what time it is sort of the answer. So what we're seeing from Dtrace is Dtrace gives you output in some order, which is not always the most helpful order. It gives you output according to where it landed on a particular CPU at a particular time. It doesn't give you output ordered by when the event happened. This is a very common problem that people encounter. Brendan, I imagine this is a question that you've had posed to you more than once.
This is why many Dtrace toolkit scripts have a switch to print out timestamps. It's so that you can post-sort the output, so it's in correct order.
Yeah, and the most common way you see this screw up, and to say it still confuses me, when I'm not thinking about it, is you'll trace, say, a function going into a read, and then you'll trace that function as it returns from that read. Now, in between entering the read and returning from the read, it might switch onto a different CPU. So depending on whether it went to a higher number or a lower number CPU, you might see, function, entering all the functions entering the read and then all the functions exiting the read, or you might see all the functions exiting the read and then all the functions entering the read. So it can be very confusing to understand the output. Dtrace has a lot of gotchas like this, and you only discover it when you're teaching people this for like the 12th time. And you're like, oh yeah. I mean, the output's not in the order you'd expect. It's some random order that we decided on. So what Matt and I did last year is we implemented the -x temporal option. So I can do -x temporal equals on, I think. And lo and behold, all of the numbers now on the far right are in order. So this is a very trivial example, but one that impacts the way you use Dtrace. Now, I can even go back and we took the very bold step of making temporal equals on the default, so I can do this and get the same thing. Ooh. So let me show you another one of my Dtrace, another favorite of mine. So Eric Schrock, who worked on ZFS and Dtrace and the system objects file system and has been all over the place, and is a Illumos advocate and new father and has many other accolades. He implemented something called the Dtrace print action. So it used to be, let's see, what's a good one? So it used to be that in order to print out a structure, I need to actually know what that structure was. So George, if I'm going to trace arg0, what are some things I can trace off of ZIO8? I think that's a ZIO2, right?
Yes. Yeah,
So
so you can look at like IOTXG, IO_TXG.
Okay, so normally what you do is you find George, or you call him, or Skype him, or no, wrong. So if George isn't around, or if you forgot, oh damn, you're right. Oh, thanks. Thank you, everyone. All right, good work, George. Thank you. So, and let's see if, oh, good. There's actually some stuff going on. Great. So, you know, we're getting that. But if George isn't around, or you don't have the structure, you don't have MDB up, and it's a real pain in the neck. So, Schrock did this great thing where you can just do print, and it'll give you the whole structure. And this is going to be a big structure. Oh, that's kind of boring, actually. This can work, right? Yeah, it's great. So we get this big structure here, and we get all of the data. You guys have seen this before, right? This is the first time anyone see this?
Yeah.
Okay. Oh, wow, great. Yeah, this is damn cool. I use this all the time, and it means like you spend so much less time like groveling through stuff. Doesn't mean you actually trace a lot more data, so you incur like a bigger probe effect and stuff. But so this is great. But the problem I had is that one of the things I use most often are translated arguments, in particular the IO provider. And I could never remember the arguments to, like, this is how I use the IO provider. It's the same way I use find. It's like man find. I'd always do like dtrace minus LV, then I'd look at, I'd be like, these are the arguments. A buff info T, a dev info T, and a file info T. Now, what would people do from here if they knew that like this was a dev info T? Because I know I have my way, but that's not the same way as anyone else. Go to the source. Did anyone say go to the documentation, Brendan? No, nobody said that. Buy the book, right?
You don't remember what the structure is?
Right. So this is MDB doesn't have it. Dtrace print doesn't have it because they're translated types. They're not real types. So what I always do is look. I just VI this file, which is where it is. You guys don't do this? Okay. Yeah. So like that's how I did it. But no more. Thanks to Schrock, and then a little to myself. So now we can do a print. Let's hope the system is doing IO. Oh, damn it. This is my first time using Dtrace. All right, so do IO. Okay, great. So now again, this didn't work right out of the gate with Schrock's fix, because these are translated types. Translated types, we don't actually compute what the value of each of these members is until you actually use it. So what we do is something kind of delightful and horrible. So has anyone ever like disassembled dtrace output? One. Awesome. If people start nodding off, by the way, I'll just move on. So if we disassemble this little piece of the ZIO code, this is what we see. We see some very simple, I used the -S flag, of course, for disassemble, and -E for exit immediately. We just do a couple of very simple instructions to record it, and we can see that this structure is 880 bytes. Okay. So for that same example, we're going to see a lot more output. So what we needed to do is proactively translate each member. So we allocate this big buffer, and then translate every member into it, and then have dtrace trace that, because until we actually construct it, it didn't exist. All right, so that was on Dtrace usability. And hecklers can feel free to point out anything else on Dtrace usability that I should have gone over. I am going to go, you want to talk about MDB? Tab completion? Yeah, but this is, okay, so Robert, who's idling here in the shadows, and our colleague Matt Amder worked on MDB tab completion, which is awesome. So I can do : print, and then do like a ZIOT, and then I hit tab, and it shows me all the members of it. And anyone who uses MDB, it's like, this will change your life. It's changed mine. Was there a comment up there? No. Great. And you can chain it along. You'd say points to this and points to the other, and so forth. So really useful. And again, one of my favorites. All right. Comments or questions? Then I'm going to go back to this part. I think Robert. Oh yeah, please.
So ZFS is named features.
Yes.
Say Joint and Delphix are working on 2 separate features for ZFS, and one goes and grabs ZPL from Joint and brings it to Delphix system. What happens?
So the question is, with Zfs Feature Flags, let's say I take a pool from Joint system and I bring it over to Delphix's system and I load it up, what happens? So what will happen is it'll say, if you have used that particular feature that's enabled that Joint system knows about and the Delphix system doesn't, when you try to import the pool, it'll say, hey, a data set here is using a feature that I don't know about. So, and here's like the long code for it. It's like com.joint : virtualization or RAMA or whatever.
So that pool is not readable at this point.
Exactly, and then that's not readable unless we can, unless you get to a system that supports that feature.
So are there now currently multiple different incompatible branches of ZPL formats?
Yes, there are, and that's the intention of ZFS Feature Flags. The intention is to enable people to make pools that are incompatible, but for lack of a better term, compatibly incompatible. So they know that they're incompatible before you try to load it in, as opposed to both grabbing, version number 35, and it says, yeah, version number 35, I know how that works, and just the on disk state not matching what we anticipated matching.
Put another way, it's better to fail to import than to corrupt the pool.
That's right. Better to fail to import than to corrupt the pool.
No, I don't disagree, but this is fragmentation and lock-in.
Well, the thing to keep in mind is that you can have features that are read compatible. So you can actually import a pool from somebody else's stack simply because it knows how to read and structure. It may not be able to write that feature.
Is there such a notion as a read compatible feature?
Yes.
Yes, absolutely. It's part of the features flag.
Yeah, so we can refer you to some more documentation on exactly how they work.
To be clear, the point of this is to enable innovation, right? So we didn't, if you take the point of view that all pools must be readable on all implementations of ZFS, essentially we would be saying no one can ever change the on-disk format, right? And we would rather, rather than letting Oracle monopolize on the innovation by changing, because they're going to change the format whenever they want to. We want to be able to say, we want to be able to innovate as well, but in a way that is more compatible. And even though SmartOS might not support a feature that Delphix OS does today, they can add in support for that later. And of course, we'll publish the source code to make that easy for them to do.
As long as those features are not basically incompatible.
So the key thing here is that Feature Flags allows businesses to make the decision when they're creating a new ZFS feature, whether to share it or not, and facilitates the process of sharing it later, so that a business can get a time to market advantage if they need it.
To be clear, we haven't. People always had the ability to kind of take ZFS and fork it incompatibly however they want it. What we've done is we've provided a structure and a way for people to then come together later. I think as Garrett is alluding to, if you're creating some feature, you might ship it and then roll it up to Illumos or not. But we're providing a way for people to participate or not and do it in a way which is kind of friendly to the community and where we're not stomping on each other's toes.
Is it a goal to eventually converge all the various branches?
The question is it a goal to converge the branches? I don't think so.
Again, it's a business decision that each innovator gets to choose. One of the neat things here, though, is that Feature Flags doesn't require there to be a ZFS authority. We don't have to vote on these things. Companies can just go and do what they want.
So I'm gonna
Let's come tomorrow to ZFS Day, and we're having a panel discussion at 1:30 right after lunch about ZFS and its implementation on all the different platforms, FreeBSD, Linux, Illumos. I'm sure that this will be a topic of discussion.
To summarize for people on the stream, come to a ZFS Day tomorrow. Moving on, another innovation that I really got jazzed for is something that Robert had worked on in the context of his work at Joyent. And since he asked me to give this talk, I thought it would be appropriate to make him kind of give a couple minutes on something I think is really neat. So,
thanks, Adam. Okay, so I'm talking about per-thread caching in libumem, and so for those of you who don't know what libumem is a library that can replace the standard malloc call in standard free, and basically provides a way of getting at the standard kernel slab allocator in a userland form. Now, a lot of people these days might ask, so why does malloc actually matter? I mean, really, malloc is something that these C programmers go off and use. They use it to cause memory leaks and increase my RSS and my V size. And you know what? I have all these nice dynamic languages, so I don't have to call malloc and free, and so I don't have to worry about corrupting my heap and doing all these other things. But actually, that's all a lie. So at the end of the day, all these systems still actually end up using malloc. So for example, take C++. You call new. What does new call? Malloc. Even these garbage collector languages, they actually still call malloc. So like I put a few examples here. So example, kstat is written in Perl. So kstat here, if you just run kstat, prints out all of the kernel statistics. So there's a lot going on. So it's over there doing about 670,000 mallocs. So that's a lot. If you just run HG, which is just the mercurial version control software, which is written in Python, there you get another 3,800 just to get out the standard usage message. Now, you also have something from SmartOS, in this case VM list, which is written in Node.js. You might say, hey, great, we're using JavaScript. You know, we have all these great VMs that take care of everything for us. We never have to worry about malloc end. That's yet a lie again, because there's another 2,700 mallocs. So at the end of the day, even if you don't actually call malloc, you don't actually write any code that ever touches malloc, malloc actually ends up being a bottleneck in your performance if your malloc implementation is slow. So to kind of keep in mind, libumem was supposed to be a scalable replacement for libc's malloc. Libc's malloc is basically from 1986, I want to say, and hasn't really been changed since then. So it was designed when you had basically one CPU, one thread, and you know it was great. But times have changed, hardware has changed, and so we had to adapt. So where libumem starts to break down is that you have to grab a lock. And you might say, okay, I have a single threaded program, only one lock, no one else is there, that's great. Well, unfortunately it's not quite so great. So if you are in the kernel, you text enter, you disassemble that, it's great. 4 instructions, you're uncontented, you're done, that's it. I mean, the kernel's malloc implementation is really designed for non-contention. I mean, basically, if you're having a lot of contention in the kernel, you need to go back and rethink what you're doing and fix that. In userland, however, it's not quite so lucky. This is probably because userland has to deal with more edge conditions, you have to worry a bit more about scheduling, and you can't exploit the same unholy knowledge that the kernel itself has to basically work around this. So the kernel is smart enough to know a few places where it shouldn't preempt you. And userland isn't so lucky. Userland can be preempted whenever we want. So part of the problem is that some applications are bad actors. And at the end of the day, it would be great if I could go through and fix every single application out there, but that just doesn't work. It's not realistic. Some of these just basically go through, they're gonna malloc and free a small string, say it's maybe 4 bytes. And they're just gonna do that because of some operation in a tight loop. It's basically mallocing, using it, freeing it, mallocing, using it, freeing it. This just goes on, and we've seen this for some programs where over 100,000 of these little loops per second. So you got a lot going there. And at the end of the day, for us, customers complain because it's slow. They don't really care why it's slow. I mean, that's why they're the customers. They get to complain. So the approach here is that rather than go through and and kind of use the traditional path, we need to actually go through and do dynamic generation of the malloc, what malloc looks like. So what we're going to do is we're going to add a per thread cache. So that means that every thread is going to cache some portion of the recent allocations for themselves. Because if you're only talking to yourself, you don't need to synchronize with anyone else. Basically, you don't have to worry about anyone else getting there and getting in your way. So libumem uses a series of caches. And if you're not familiar with the slab allocator, I highly recommend that you go read Bonwick's papers from '94, which really go into that in detail. And these caches basically are at fixed size. So you have one like 8 bytes, 16 bytes, 32 bytes. And it kind of goes all the way up to 128K. And when you do an allocation, you come in and you basically get satisfied from one of those caches. So instead, what we're going through and doing is that in umem, as libumem basically starts up, because you can dynamically change the set of caches at runtime, basically as the program executes, you actually can't compile in this information. So you need to dynamically generate this information. What we do is that we kind of coordinate with libc, and in the thread's uber data, which is basically the userland version of a k-thread-t, basically a per thread data structure, we basically maintain a linked list of each of these heads, basically each of these caches. So we can use this to go through and dynamically generate assembly that goes through, figures out which of these caches to use, and returns the allocation. Then when a thread would free the memory, it puts it back into that. And when the thread finally exits, the thread will free all of its memory back to the main system. So basically just to kind of put this in perspective, just to kind of make sure we were actually doing better, and just to kind of actually make sure we did a good job and didn't regress anything, we went through and basically compared in a few different cases. In this case, this is comparing us to glibc, which has a lot of really good work in it to kind of go fast. But basically, we're just looking at different cache sizes, which are going through, and we're just basically timing how long does it take to do, say, 512 million iterations, and just kind of averaging those across over time. The nice thing we see here is basically kind of a nice, mostly linear increase with respect to cache size. And since we're still within the first 16 cache sizes, these all happen within microseconds as opposed to taking much longer. Peeking under the hood, this is actually what a bit of the source code looks like. So what you're actually seeing there are basically tables of opcodes for x86, where we then go back in and we basically dynamically fill in the numbers. And basically fill in all these offsets based on what we know at runtime. So these slabs get copied across. If you look above, you can see kind of what the C pseudocode would look like. Then you can see what the actual assembly instructions are. Then there are basically holes. Those offsets, those hash defines are all basically offsets that we know where to go and copy stuff into. And all this is much better documented inside the libumem big theory statement and on my blog itself. And that's really it.
So I realized you thought I was going away, but really I was just stepping aside for Robert. I got like a couple more slides for you. So the reason I thought I really wanted Robert to present his stuff is just because I think it's so whizzy and cool, but also so reflective of what we're doing in Illumos. How we're, I think, closing that loop between customer problems that we see in our businesses, and the solutions that make it upstream. So never's a long time. So when I said, let's talk about the innovations that are in Illumos that will never be in Oracle Solaris, that's something we can really kind of talk about. Here's the problem. We have fundamentally different problems that we're looking at. We're encountering problems in our businesses, we are innovating in our businesses, and we're going off in a very different direction. Oracle's directions are, again, the system administrator, packaging and install, and Spark. Robert, all that stuff works for Spark, right? No, of course not. So, they're disjoint problem sets. And so, while it's conceivable, I suppose, that Oracle could want them or want to take them, but to me that just seems very unlikely given that we're going in such different directions as communities and as businesses. And even then, I think the licensing, which was such a good decision for Sun, I think, has become a real, or would be a real problem for Oracle. I think there are certainly bug fixes even that we've done in ZFS and Dtrace and the core stack that Oracle would like to pick up, but doing so would mean that they would need to release all of their source code that they've accumulated, which is really anathema to their business. So I think it is safe to say that the innovations we're making in Illumos aren't going to show up in Oracle Solaris almost across the board, in part because of licensing and because of NIH and because of their business, but also in part because we're just doing different things and care about much different innovations. Oh, and this is a picture I took not an hour ago. So this is from the Dtrace Linux talk that was given down the street at Oracle Open World. Pardon?
Is that the card?
That's actually what I thought, and I thought someone was going to be a jerk for me for saying, pointing out the ball guy. But yes, that is Jean-Luc Picard in the front row. I got his autograph. And so, output is not time ordered in Dtrace, but of course it is now. So thank you very much. And if we have a couple minutes, I'd love to hear other questions, and if there are other innovations people want to talk about.
So I know that there's a few things that are going on in the protocol stack. So there's enhancements that have been made to iSCSI, and I think there's stuff flying for NFS. So
yes, there's lots of stuff happening, throughout the OS stack. I picked some ones that I didn't even necessarily think were representative, but were just ones that I liked and I think are really wizard. Which one did you? Oh, Regood. It is kind of killing the ZFS test these days, but but yes.
Not anymore.
Not anymore. Part of it. All right, great. Thanks very much.
Okay, with that, we are back on schedule, and Chris Nelson is up. Thank you for taking up that gauntlet. For anybody who's hot, this conference nice and cool down here.